Dr. Báez-Mendoza, welcome back to our second part of the podcast, where we talk about challenges, problems in academia. By tradition, I start by just, summarizing some of the things, and I let our guests choose whatever they want to share with us. And basically, every person so far shared very interesting stories that have nothing to do with the others, which is cool because you will learn a lot of different perspectives, right? But the thing is that in life science, we have this kind of vicious circle. You have to publish to perish, publish fast, the best in the high-ranking journals. Unfortunately, the publishing process takes time, half a year, even 2 years for a paper to be published. On the other hand, you have granting agencies that look of your history of publishing and impact and involvement in also different projects, communicating science. But if you don't have these papers, then it's hard for you to get access to funding, which of course leads to this disadvantage that you cannot continue your research, right? And this is kind of one of the publishing granting system problem. Then we have the so-called postdoc crisis, where quite a lot of highly trained PhD students, they continue, let's say, for one postdoc, and then they just cannot find a job and they leave academia. Of course, everybody can decide for themselves what to do, and there are plenty of working places outside of academia for these kind of people, but the academic system has difficulties keeping such people, for example, as staff scientists that actually can train others and are very valuable for very good working institutions. Then you have in many occasions problems with reproducing results. Now, especially we talked about monkeys. Sometimes you have 2-3 monkeys, which might be considered less number, of course, for example, in my case, where we work with a lot of antibodies and microscopy, you're dependent on these antibodies. And when if you guys are familiar how antibodies are produced, they are derived from animals, let's say, and if a certain animal die, then you lose this kind of antibodies. So there is a problem of reproducibility. And we have many others, many other aspects that we can discuss, but maybe as a person who has tremendous experience in 2-3 continents, I don't know how many exactly, and top-notch institutions, what do you think should be changed in your opinion?
Yeah, well, that's a lot of topics. You're challenging my memory now. But so I would say let's just kind of go part by part. So part of the scientific enterprise is to, what you're, if you just think about it in terms of a scientific enterprise, like your company, my lab is my company, and the input is that we get is we get injection from the government to produce an output, which is going to be papers. And the more output we produce, we get more input, like more funds. So I think that's, in this kind of very simplified system, like you of course, like the more output the better quality of your product, the more money you can get. But you can also get more money if you produce just a lot more papers, more output, just of any quality. I think that's something that it becomes a bit of a at the lab level, what people have to decide what they want to do, if they want to focus more on quality or quantity, or if there's a way to do both. Then you have to, but then, like, of course, you need to figure out how the government or the funding agencies, the private foundations, are gonna fund this work so that there's certain output. So there's different models being played out. So a model that I think it's has a interesting appeal in terms of being very democratic, might not be very meritocratic, is to do a lottery. So you have a certain threshold, and you assign funds based on a lottery. Basically, you have 10 applications, 5 of them are of the good enough quality, and then there's a lottery process, and one of them gets funded. And that way, you are, helping all of the labs to produce interesting outputs. So that's something that it's been floated. It has not taken off. I think it would be interesting to see that, but of course you need a funder willing to take that risk, and I don't know. And we're talking about again, risk in terms of uncertainty. Like, you don't know if this is gonna work or not. But yeah, so the bigger labs get bigger, and kind of the rich get richer, because you have the capital to take more risks. Try projects that are much more challenging, and so those can produce a big outcome. Like a high impact paper, but they can also fail, and that's most likely the what's going to happen. So how do you do this? How do you avoid this? Having these very big labs. I think they can be super productive anyway. So I don't think that you really need to get rid of them. I think it's imperfect. And definitely more money would be better, because that would give us the opportunity to take more risks and take more opportunities. And to, as you were kind of also mentioning, like, you have this amazing pool of talent of scientists that I really want to keep going, but they can't, because there's not enough money to fund them. So I mean, it sounds very simple. It's not that simple to do this, but if you increase the general budget for investment in science, then that's as a government, that gives you the opportunity to keep growing, keep creating these opportunities for people to take more risks when creating basic science, and that can also translate into findings that can be used in for technology that is more commercially available, and to keep this growing talent of scientists that might be deciding to do something else because of lack of opportunities.
Yeah, it's a very interesting idea about the lottery, but I don't know if it will take off, because let's say if the government has a certain idea to boost AI, they will definitely probably fund more AI research related projects, right? And having the risk of taking the lottery and funding something like different would be, I think, not appropriate for the funding agencies. But it's interesting idea. I haven't heard it so far.
Yeah, I mean, you just need I mean, maybe not. Maybe the government might not be the right, but like a foundation, if they decide, okay, let's just try this, and I think that's something that would be really,
that's
really interesting.
It's cool. I mean, unfortunately, in Europe, we don't have that many private funders. Not like as in the US, you have these crazy big foundations that pour money into whatever research, and it's really, really incredible. But in Europe, people are more like conservative. I don't know. They don't do that for whatever reason. I don't know. But how do you follow the current things that are happening in the US?
Yeah, I mean, I read the news and talk to colleagues, and
How do you evaluate this kind of development of the situation there?
Well, so so you have several kind of forces playing out. I would say so the current so the government decides where to invest. You were just mentioning like, if the government wants to invest in AI, the government is going to invest in AI, and they develop these schemes to do this. And as far as I understand, the government in the US, for several decades has been investing heavily into biological sciences and basic biological sciences. They had the Amazing Brain Initiative, injecting a ton of money into developing new technologies to try to understand the brain, and that has resulted in amazing science and amazing technological advances as well. But now with the new government, this has changed. Like the priorities have changed. They have changed dramatically, I would say. So we're kind of used to kind of slow government, bureaucratic government, kind of following all the rules and checks and balances and whatnot. But this has changed quite fast. So it's quite obvious that this has changed, and now the priorities are different. So that brings a lot of uncertainty to when you're doing science, because science is a slow process mostly. It just takes time to design experiments, plan them out, get the funding, get the people to do the experiments, analyze the data, write it up. It just takes time. All that. We just talked about this pollution process also taking time. So so that circumstance has it will make on the short term going to the US less attractive for a very international workforce. So scientists are a very international workforce, like where we can be very mobile. It's amazing, like to through science that you can live in so many different countries. That's something I loved about science, and science has allowed me to live in all these different countries and have all these different experiences. So it just kind of allows you to do this, and people that don't feel that their work is or that their work is in peril, they will decide to go elsewhere. So my prediction before this was that there was going to be a temporary brain drain from the US, and there's going to be a brain gain elsewhere. So that depends also on how the governments decide how to do this, how if they want to benefit. And we know about the new schemes here in the European Union, or that France has enacted to attract talent. And that's a little bit what we also saw during Brexit. Like people left the UK because they felt like this is not compatible with how I want to live, and so they moved, or for any reason, but they decided to move, and a lot of other countries benefit. One of them was Germany, for sure, where we are right now.
Very interesting. Yeah, I also think that this brain drain, but to some extent the brain drain was from the rest of the world to the US. Now it will be the other way around. So it depends at which direction the wind flows, but it's definitely not good for people who, I read some articles about research that is just stopped in the middle of the process. So you basically, as you said, you have to think of experiments, write grants, get the grants, find people, and then this takes 3-4 years to execute everything and wrap up papers, even in the best case scenario, right? And then in the middle, if somebody says, okay, now no funding more, then what do you do? What do these people do that just came here to work? It's incredible what is going on. And I really wish that all of these people find jobs as soon as possible, right? And their families won't be that stressed, and things will turn out at the end. I'd like to finish with a positive notion about scientists that can work everywhere in the world, and it's incredible that you can learn whatever you want basically just by writing an email to some professor or scientist, wherever in the world he or she is, and then you can just go there eventually, learn this technology and apply it to your research and your questions. Dr. Báez-Mendoza, thank you very much once again for sharing with us your opinion on the challenges in academia.
No, thank you very much for the opportunity to talk about this, and yeah, thank you, everybody.